Hi everyone, we can start the session for the day. We'll be talking about the networking service that is available, and essentially it is referred to as VPCs, which helps you build virtual private environments in which you can provision your resources. Okay, moving on to the contents of session. Essentially for the larger part of it, we'll be talking about the VPCs, what are the various components from a network perspective that are available within VPCs, and we'll do a comparison between default and non-default VPCs. Recall, when you sign up for your AWS account, Amazon creates a default VPC for you. So there are multiple reasons that you might want to create your own VPCs. So they are known as non-default VPCs. So we'll see the use cases why we need non-default VPCs. And then we'll understand the process or the way to create your own VPCs, attaching various network components that you might need to establish connectivity outside AWS. Then we'll also talk about on various methods available to connect to AWS from outside AWS. So we can use VPNs or we can use services like Direct Connect to help you connect to AWS. So that would ensure a secure channel between, let's say, your corporate office and AWS. So moving on, we'll start discussions around VPC. So essentially, it is one part of the foundation services. Recall the illustration that we have been going through time and again. So refer to this illustration. Networking is part of foundation services, and essentially, this is the first service that you need to be familiar with, because on top of your networks, you actually provision your various other components or services. So VPCs, they essentially allow you to provision a logically isolated section of AWS services cloud where we can launch AWS resources in the virtual network that we have defined. So in real-time basis, it is very similar to what we do in traditional environments in terms of defining or creating a network for your traditional environment. So the process is very similar. And we as customers get complete control over our virtual network environment, including selection of own IP address range. So this is a very important aspect, that you get to choose IP address range of your choice. That's simply because, so let's say this is AWS. So this could be your CO or your data center. So any environment outside AWS. And let's say the inner circle is our VPC that we have created. So one of the benefits that VPC gives is any resources now that you would provision them inside the VPC that you have created, creating a logical isolation layer. Secondly, you get to choose the IP address range of your choice. So this is very important. So one of the fundamentals of networking is that if two networks want to communicate with each other, their address ranges should not overlap. So if you want to integrate environments within AWS or outside AWS, their network address ranges should not overlap. So imagine a global company which has multiple offices across the globe, and you want to set up connectivity across AWS. So selection of IP address ranges becomes pretty detrimental. So in larger organizations, you'll see dedicated teams who actually manage the IP address space for the organization, so that when it comes to integrating remote offices to corporate offices, or for that matter to AWS, they ensure that the IP address ranges do not overlap. So once you have a selected IP address range of your choice, you can create multiple sub networks within the network address range. So sub networks would allow you to place various components accordingly. So let's say for a three-tiered architected application, I create three sub networks. So the first sub network could belong to my presentation layer, which could be my web service layer. The second layer or the second subnet could be related to application services. The third layer, the third sub network could be dedicated to database services. So you can control the traffic flow, both incoming and outgoing, at the network layer as well. So at the compute layer, we saw security groups, but at the network layer, you can implement another security layer. So that would help you in securing your architectures. So just let me log on to the AWS console. So for any service that we provision, we do get an option to select the underlying network, so which is referred to as VPCs here. So for example, in EC2 section, when we provision an instance, you have the option to select the VPC out here. So in this case, we have always used the default VPC, but we can create our own VPC. So in this example, I have a VPC by the name development. Then the second aspect is with respect to availability zones. We have been talking about having workloads distributed across multiple availability zones. So essentially, if we look at it, so there'll be a default network address range assigned to this default VPC. Within that network address range, you would have created multiple subnetworks and you assign each subnetwork to each availability zone. So in generic terms, we use them as availability zones, but essentially it is the mapping of subnetworks to availability zone that is done when you set up your own VPCs. So likewise for any other service, wherever you get an option of selecting the network. So if you have already created your own VPC, you can always choose that. So a lot of organizations actually adopt having multiple VPCs within the same account. So let's say you have multiple environments running in AWS, starting from dev, QA, staging, production. So you may want logical segregation of resources. So for all the resources that belong to development, you will provision them in the development VPC. And likewise, for every other environment, you will do the same. So you see a logical representation out here of a VPC. So VPCs are again specific to a region in which you want to provision your resources. And you see multiple availability zones. So essentially, you are mapping your subnetworks to each availability zone. So let's say my VPC address range is, I'm trying it at a very broader level so that guys coming in from network background or non-network background are able to relate to the concepts. So let's say we decide a range, let's call it as R. We create two subnetworks from that range, R1 and R2. So I'm mapping R1 to one availability zone. So let's say A, and R2 as the another availability zone. So generally we would say availability zone A. So indirectly it would mean that in the backend, your network teams would have mapped it to subnetwork address range, which is R1 in this case. And then you see a couple of components. You see the term router being used here. So this is a layer of abstraction. So this is something that you don't have control over. So we have seen that resources can communicate even if they are placed across multiple availability zones. So this is something that Amazon handles for you. And then you have a component called Internet Gateway, generally referred to as IGW. So for your default VPCs, this comes pre-configured, and Internet Gateway is network service that helps your resources within AWS to communicate to resources available outside AWS. So in this case, you're connecting to internet, and then likewise, the same logic can be applied for the traffic that is originated from internet that is coming to your VPC or directed to your VPC. The multiple benefits, we have spoken most about all the benefits. Single tenant hardware, which means dedicated tenancy is available within a VPC. Create a layered network of resources. So let's say for any application, 3-tiered, 4-tiered, or multi-tiered. So you can create many sub networks and then you can control what traffic that you want to allow or disallow. Essentially a way of filtering the traffic at the network layer. Then you can use IPv4 to your instances, which persist your start and stop, which is this is a reference to elastic IPs. And then EC2 instance security groups can be changed. So we have already seen that security groups are applicable at the compute layer. ACLs are more relevant at network layer, wherein you control the traffic from one subnetwork to another subnetwork or any traffic that is coming from outside AWS. So you control both outbound and inbound traffic, and you can have multiple network interfaces to EC2 instance. So the reason we see these arguments, when AWS actually started out, concept of VPCs was not there. So which meant that almost every customer was sharing the same network, so which was a big security threat. So for all those legacy customers, they had a path laid down, and when the VPC service was announced, they had advised them to create their own VPCs and migrate their resources to their own VPCs. So a quick comparison on default and non-default. So essentially, these are configuration parameters that you can always change about, wherein the non-default VPCs, you'll have to set everything on your own. Whereas with default, it comes up with at least at a level where you can start provisioning resources and start using it. But as I said, if you want to integrate environments outside AWS predominantly, you'll need to create a non-default VPC where you define the network address range of your own choice. So default VPC is created by AWS. So you can choose while provisioning any service a VPC of your choice, and we'll see mapping of various subnetworks to various availability zones. All the commonly used features are available within default VPCs. And as I said, in non-default VPCs, you have to set up everything right from creating subnetworks, various other components such as internet gateways, virtual private gateways, NAT gateways. This slide sums up various components that you can set up within a VPC. So the first component that you might want to set up is internet gateways. So again, you would want your resources that you're provisioning within AWS to communicate over internet. So internet gateway is the service that would let you achieve that. Then NAT is network address translation. So I'll talk about NAT. So essentially for the servers that you want to be highly secure, let's say a database service. So you don't allow internet access to database services directly. So there's an indirect way of providing internet access for your, let's say, database services. So that helps you build another layer of security at database layer. So any service that you want to keep very, very secure, but still there might be legitimate need that that service needs access to internet, you won't go via internet gateway directly. You would rather use a NAT service. Then you can implement DNS within your own VPC, set up elastic IPs. We have already seen that, VPC endpoints. So this allows you to connect your environments outside AWS. Then route tables. This is where you get to set rules on how you want the traffic to be routed. Network interfaces we have already seen. They act as an entry and exit point for your EC2 resource. So a bit of a primer in terms of IP addresses, logical addresses that help you communicate resources in a network, and two components of IP address. The first part is referred to as the network ID and the second part is referred to as host ID. And it is the subnet mask that helps you determine what is the network ID and what is the host ID. So if you see the decimal notation of the IP address, so this is what we commonly used. In the backend, we use binary notations. So for ease of remembering them, we use decimal notations. So you see the IP address followed by a slash. So the number that you see after the slash represents the subnet mask. So if you were to perform a binary operation, which is a logical AND across this address, and /19 would translate into network ID and the host ID. So again, we see the explanation out here. /16 refers to the subnet mask. And as we said, there are two components of IP address. One is network and one is host. So number of hosts that we can have within in this network would be 2 raised to power the number of bits that you see out here. Again, this is something that you can get the information from your network teams. So IPv4, 32-bit address. Anything that you see after the // is the subnet mask. Total number of addresses available, hosts addresses would be 2 raised to power number of ones in the host ID. So then you have IPv6 addresses as well, wherein IPv4 addresses were about getting exhausted since the usage over internet grew exponentially. So they introduced IPv6 that allows for more number of hosts that can be accommodated. But with the invent of NAT, IPv6 never really took off in a way that it should have been. So NAT allows you over, let's say there are thousands of users. So let's take an example of a service provider. So a service provider would actually use only one IP address to translate close to 60,000 addresses. So that way, the advent of NAT actually drastically reduced the IPv4 addresses, which were kind of getting exhausted at a point of time. So again, what is a subnetwork? So you want logical segregation for a specific component of our application. So let's say you have web tier, app tier, and database tier. So in this example, you might want to create 3 subnetworks within the address range that you would have specified. So creating a tier layer of resources gives you multiple benefits. You can control the traffic, what is incoming and outgoing, and logical grouping of resources in one subnetwork. So allows for easier management as well. So in the example that you see out here, you have marketing teams and technical teams. So in your office environments, you can control the traffic from network perspective as well, wherein marketing team cannot access technical team resources and vice versa. So subnet mask, we have already said that it helps you define what is the network ID and what is the host ID, and you perform a binary AND operation to get what is your existing network ID and what is your host ID. Then you have various classes, class A, B, and C. So for IP addresses, there are two types. One is private and one is public. So public IP addresses, those resources are associated with public IP addresses. They'll be accessible over the internet. Whereas for private IP addresses, they are used for inter-node communication purposes only. So there are predefined private address ranges that any organization can use. But if the need is to access internet resource, it has to be masked with a public IP address. So in your organizations, you'll be using private IP addresses. Anyone who's using an internet connection in the background uses private address range. And let's say you're in office, you fire a printout or you're accessing your file servers. That communication is happening over private address ranges. So for example, if you're in your office and you want to access internet, so how do you access internet? So to do this, you can use NAT, which is Network Address Translation Service. So for example, so there are three designated IP address ranges that you can use, which is 10 series, 172, and 192. So this is a private address range that has been assigned to my laptop, but I'm still able to connect to resources over internet. And in fact, we all are in a webinar. So that means in the background, service provider in this case is performing address translation, wherein it maps this private address to a public address. So another thumb rule from network perspective, any resource that needs to be accessible over internet has to be directly or indirectly associated with a public IP address. So if I want to check what is the IP address that internet sees for my request, this is the address, which is a public address range. So the translation from 192 series, in this case, 192.168.1.12 is being translated into 27.6 onwards by my service provider. So NAT gate service helps you in this kind of a translation where your private addresses are mapped to public and vice versa for the reverse traffic. When it comes back to the service provider again performs a translation, which in that case would mean translating 27.6 to this address. So you can use both IPv4 and 6. So IPv4 is predominantly used all the times, and you get to choose your own address range, and the subnet masks should be between 16 and 28, and all the instance types that we see, general purpose memory, compute, they are supported, whereas elastic addresses are also supported. So there are limitations with IPv6, and if you're planning to have a very, very large network in excess of multiples of thousands, then you might want to consider using IPv6. So private and public addresses, and likewise at the network layer, we refer two terms, public subnets and private subnets. So these are purely the naming conventions, and until you configure them appropriately, you really can't use these terms. So by definition, a resource that you place in a public subnet, your intention is to make that resource available over the internet. And likewise, for a private subnet, as the name suggests, you don't want the resource to be able to access internet. So if you want resources placed in private subnetworks, in that case, you'll have to provision a NAT service. So for database tier, we already said we'll provision them in a private subnetwork so that it does not have any association with public IP address. And if it needs to access internet rather than going through the normal channel, it would go through the NAT process. So internet gateway, let's do it in the demo directly, and let's see this. So let's say this is you and you have three destinations. Let's say D1, D2, and D3. So D1 could be your office, D2 could be supermarket, D3 could be your home. So now if you were to relate it with various components that are available. So let's say we have multiple exit points. So let's say you have exit 1, which is connected to D1. You have exit 2, which is connected to D2. And likewise, you have exit 3 that is connected to D3. So in order for us to go to D1, I'll have to go to E1 in this case. For destination D2, I'll have to take exit 2. For destination 3, we have to go to exit 3. So we can apply this model on network services as well. So you need to know which destination you want to actually go and then appropriately select the exit or the network service that would take you to that particular destination. So applying the same concept, so you have your AWS, you have a VPC unit, and within this, let's say you have specified that I have private and public subnets out here. and my destinations I'll replace D1, D2, and D3. So let's say this is internet. This is your corporate office or data center running outside AWS. This could be another VPC, and last destination would be, okay, I'll come to the last destination in a bit. So now let's say if my resource is placed in the public subnet and I want to access the resource over the internet. So I'll be setting up multiple rules wherein I specify the rule that would be applicable to the public subnet, that if you want to reach out to internet, please take the exit E1. So E1 is equivalent to IGW in this case. So any traffic that is destined for internet, IGW would facilitate that connection for you. Likewise, from public subnet or private subnet, you want to send the traffic or set up a connection mechanism between your corporate or your data center environments. So in those cases, you'll have to set up a rule that sends the traffic to another network service, which is referred to as VPG, which is Virtual Private Gateway. If you want to set up connections across multiple VPCs in the same account or other account, there is another service that is referred to as VPC Peering. And then lastly, we have NAT. So again, resources placed in your private subnetworks, generally database services. If they need access to internet, you'll be sending the traffic to NAT service. So setting up of these rules out here, let's say this is rule R1, R2, R3, and so on. These are referred to as route tables on the network side. And we've spoken about various components. You have IGW, so it facilitates connections to internet from resources within AWS. VPG facilitate connections to resources outside AWS. Then you have VPC peering, multiple VPCs allows you to set up a default method, and then NAT gateways for resources placed in private subnets. So I've spoken about IGW. That's a component that helps you communicate between your resources and internet by providing the targets in the route table. So by setting up rules in your route table, wherein you redirect the traffic to internet gateway to access internet resources. So route tables or the rules are created at sub-network level. So let's say if you have a multi-tiered application, so let's keep it simple at this point of time. We have, let's say, only two tiers, web and the DB. So at each layer, I can associate a set of rules. I can apply the same set of rules to both. I can have different set of rules for each subnetwork. So in this example, the illustration that you see, you have a EC2 instance. It has both private and public IP address associated with it. So when you provision an instance, recall that you have an option to auto assign public IP address. So in the default VPC, this option is enabled always. Whereas in the custom VPC or non-default VPC, this is disabled. So you can always go ahead and change it. So in this case, your instance has a private IP address and a public IP address. This is more of a direct one-to-one mapping. So the request from this EC2 service to outside world would actually be seen from this IP address, which is 203.0.113.17. Route tables, again, we have seen that for sending the targets to specific destination, you set up rules. Route tables are a way to specify those rules. Route tables, we have spoken about them, that each subnet has to be associated with the route table. Then your VPC comes with an implicit router. So this is this one's layer of extraction. So this is managed by AWS in the background. We can create our own route table, and then we cannot delete the main table. But you can always create your new route tables and not use the main route table. So what we'll do is we'll create our VPC. So before we go ahead and create the VPC, couple of things that we need to do beforehand. You'll need to know the network address range, which you will be using to create your own VPC. So this you can get from your network teams. Secondly, you'll need to create various sub-networks within this range. Again, this information will be supplied by your network teams. So we have created three sub-networks from this network address range, and we'll be mapping these to, let's say, AZ1 in this case. So we have AZ1. So we have a three-tier application. So we're creating three subnets, and we'll be mapping these three subnets to AZ1. But we have always said that use multiple availability zones for high availability and fault tolerance. So likewise, I'll need 3 subnetworks for AZ2. So if I want to add more AZs, I'll again need to create multiple subnetworks. So for AZ2, again, we'll apply the same approach. So this is some pre-planning before you actually go ahead and create your own VPCs, get the network address range, create subnetworks, map them to different availability zones that you intend to use, and then move on to the configuration part, which is we'll see is pretty straightforward. So for the demo, what we'll do is we'll not create a 3-tier, but we'll create a 2-tiered architecture, and we'll designate public subnet. And so essentially what we are doing here is this is AZ1, this is AZ2. So this would be mapped to 1075.1.0, and this is our public subnet, and the second subnet would be referred to as private subnet. And likewise here, this would be our public subnet, and this would be our private subnet. So for my web servers, I'll be placing them across 2 availability zones in the public subnets, and my database services in private subnet. Okay. So make sure you are in the right region in which you want to provision your VPC. Okay, so this is the default view that you would get on your VPC dashboard. So there's a default VPC, and the network address range that is being used by this VPC is 172.31. So any resource that we provision within this VPC would get an IP address from this specific range. So for this range, there'll be multiple subnets available that would have been created by Amazon. And for this subnet, they're using the subnetwork address ranges that Amazon creates directly for us. So give it a meaningful name so that you can identify. So let's call it staging. You need to specify the CIDR block. So this is the network address range that we have decided that we'll be using this range to create our VPC. Tenancy, we'll keep it as default. So pretty simple step, create VPC, give it a name, assign the network address range that you want to use. The second part is to create various subnetworks, and we'll be using these ranges for various subnetworks that we want to create and map to respective availability zones. So let's call it web tier public subnet and specify the VPC in which you want to create it. So let's say we want to map it to AZ1 and specify the range that we defined in the spreadsheet. So using the similar process, we'll be creating 3 another subnets. So again, I'm mapping it to 2A. So I've mapped 2 subnetworks to the same availability zone. And now likewise, I'll do it the same for the second availability zone. So let's say AZ1. So this time I'll select AZ2. So our baseline environment is ready. But we haven't provisioned any network component within this VPC. And however, it will still show us the VPC would be listed in the dropdown when you try to provision a resource. So we do see that the staging VPC is available. So you can actually go ahead and select this VPC. So the moment I do it, the public IP address assignment goes to disable. So you can always go ahead and enable it. So I'll say yes to it. Next part of the process is pretty similar. You'll see all the 4 subnets that are available. So we created 4 subnetworks, mapped it to different AZs. So I'll select public subnet for AZ1. The second instance that we'll be provisioning, I'll provision it in subnet AZ2 for my resources to be segregated across multiple AZs. So the instance is running. If you take a look at it, the private address range that has been assigned to this 1075.1.80 is part of this range. So I know for sure that any resource that gets IP address from this range is mapped to AZ1 and is a public subnet. So even though we haven't done anything at this point of time to make the subnet either public or private. So now since there is no network component attached to my VPC, I'll not be able to access this instance because we haven't set up any network component. So if you need your resources to be accessible over the internet and establish communication, the component that we spoke about was IGW. So unless and until we provision the IGW and apply rule or modify the route table that is associated with this specific subnet, I'll not be able to connect. So what I'll do is I'll go ahead and provision an internet gateway first. So it's again option available on your VPC dashboard. The initial state is deattached, which means it's not attached to any VPC. So I'll attach it to the VPC. So we'll attach it to our staging VPC. So now this internet gateway is attached to our VPC, but still there's one more configuration that we need to set up in terms of setting up of rules or route tables. So I'll go ahead and create a route table. So I'll name it as, let's say, staging. So I just created a route table by giving it a meaningful name, and I'll specify the rules within this route table. So internet destinations, they are referred to as unknown addresses. So they are typically referred as 4 times 0/0. And select the target endpoint. In this case, the target endpoint would be IGW. So I'm sending all the unknown traffic, which means traffic outside AWS, to IGW. So I've created a route table and it's sitting idle. I haven't made any associations. So I'll make subnet associations. So I'll select both the public subnets that we just created. So now we are good here. So now if I try to access the instance, I should be able to access the instance now. So I've logged in to the instance. So that means I was able to establish connectivity over internet to this particular instance. And also note that this instance was associated with a public IP address. From this instance, if I try to access any resource outside, let's say any resource on internet, let's say yahoo.com, I should be able to access it. So IGW is the main component that helps you connect to internet resources. Next part of the demo, what we'll do is we'll implement NAT, which means we'll provision a resource in private subnet, and rather than providing a direct connectivity, I can set that up that instead of sending the traffic to IGW, which could be a security flaw in your design. So rather than sending the traffic to IGW directly, you'll be sending it via the NAT gateway. So you see an illustration out here. You have a database server. So the web servers, they send the traffic directly to IGW. Whereas your database servers, instead of sending the traffic to internet gateway, they would be sending the traffic to NAT gateway first, and then NAT gateway would send the traffic to IGW. So that's the workflow. So the benefit of this approach is this web server can access the internet access directly, but exposes the public address of this instance. So anybody can use this information and try to hack your instance. Whereas if you're using a NAT gateway in between, your database servers are not being directly exposed. What is being exposed is your NAT gateway public address. They cannot pass through NAT gateway and reach your database servers. So that's one of the reasons you don't provide a direct method for resources that you want to keep private. So parallelly, what we'll do is we'll do two things. Let's say we are provisioning a database instance here. So we can choose our VPC. Let's keep it in AZ1. And this time I'll not assign any public IP address to it. So no one can access it from outside. So this rule becomes irrelevant because I'm not assigning any public IP address. So anyways, I won't be able to access it, but I'm just keeping it for now. I'll show you an indirect method to get into database services. So meanwhile, the instance gets provisioned. We'll go to NAT gateways. process is pretty straightforward. So we'll provision it in a public subnet, and let me check out which all subnets are public. So I'll say create a new elastic IP address that would be assigned to the service. So this is the IP address that it has assigned. So internet would see the requests coming in from this IP address. Since the resources that we place in private subnets, they are not associated with any public IP addresses. So their requests would be translated, whatever private IP address they get, this address. Meanwhile, the service gets provisioned. Let's take a look at whether the database instance has been provisioned. So the instance has been provisioned and it is not associated with any public IP address. So the only way I can connect to it is using private IP addresses. But over internet, private IP addresses are not reachable. So what I'll do is I'll log into my web server, which is web1, and from web1 I'll try to access this specific IP address. So now for me to access this server, I'll need to transfer the private key file that I'd associated with the instance. I'll just copy the private key file. So I'm using WinSCP to transfer the private key file. So I've copied the private key file on my web1 instance and I'll just so I'm logged into my database instance via web1 and it's 3.78, which is correct. So now if I try to access internet from this instance, I'll not be able to access it simply because there's no route table attached to this subnetwork in which the resource DB1 to be specific has been placed. So even if I associate public route table with this subnetwork, it will still not work because there is no public IP address associated with this instance. So what I'll do is now that the NAT gateway is available, I'll create another route table, create it under staging. So now again, the destination is internet. So 40/0 and target would be NAT gateway. Just select the NAT gateway out here. So the moment I do it and associate it with some specific subnetworks, so I'll associate it with private subnetworks that we created. So now I should be able to access internet from my database machine. So this is how you establish indirect connections to internet via NAT gateway. So this is another layer of security that you may want to introduce because there are legitimate needs where let's say you need to download updates. So there are new major minor version releases, patching up. For all these needs, you will need access to internet. So using the NAT gateway service, you can do it. Also, since the service is managed, so you can be rest assured about the service availability, number one. Number two is about performance, wherein whatever bandwidth that you consume, let's say you're downloading at 1000 gigs per second, the service gives you that flexibility to get the bandwidth that you want. So there are two ways that you could implement NAT. We have already seen NAT gateway. So it is a managed service and the device availability and maintenance is Amazon's responsibility. Whereas there's another way you can spin up your own EC2 instance and use that instance for the address translation. The only difference here is that in this case, you are managing the entire show and based on your instance type that you have selected, it could create bottlenecks with respect to performance. Also, with respect to availability of the service, you will have to think of ways on how to make the NAT service always available. So a quick comparison between NAT gateways and NAT instance. With respect to availability guaranteed by Amazon, for NAT instance, you will have to manage the health of your instance. Bandwidth can go to up to 10 gigabits per second, whereas on your instance, it would depend on the instance side maintenance managed by AWS, self-managed. cost, again, amount of data being transferred and number of gateways being used. In that instance, again, type of instance that you are using. So VPC peering, the idea here is segregation of resources. You could create multiple VPCs based on a specific project or a specific environment. So use cases are endless, and you can pair VPCs within your account as well as VPCs in another account. So there's another strategy that companies follow rather than having all the VPCs in one account. So let's say I create two accounts. So I have a couple of VPCs running out here and a couple of VPCs out here. So this could be my prod environment. So I totally want to keep it secure. I don't want to create it within a same account. So in this case, again, the concept of VPC peering would still apply. These VPCs can still talk to each other using VPC peering. And likewise, VPC peering can be extended to VPCs that are in other accounts. So there's a process wherein, let's say this is the requester, and you're trying to access any of these VPCs in either in account 1 or account 2. So they would become the approver. So once you approve it, the endpoint would be available to you. But again, for VPC peering, the fundamental remains the same, that the network address ranges should not overlap. So you'll need a careful network design if you're implementing multiple VPCs or want to extend your VPCs to outside AWS environment. Also, until very recently, this was only applicable within the same region, but now this could be in region 1 and this could be in region 2 as well. So VPC peering the support has been extended across multiple regions now. So again, this is a default method provided by AWS. Managing the service is Amazon's problem, and there's no single point of failure for communication or bandwidth bottlenecks. So many a times what you would see is you have database service running, let's say for lower environments, you are sharing the database service, but they're still in different VPCs. So you can actually go ahead and set up VPC peering, and that would allow resources from other VPCs to connect to your database tier. So again, the working of VPC peering is very similar. Set up the service. So in this case, we are looking at two VPCs with two different network address ranges. You'll have to set up route tables, make sure security groups and ACLs, which are access control lists, permit the traffic from one VPC to another. That's about it. So setting up a VPC peering connection is straightforward. Go to the VPC dashboard. You have peering connections available out here. Create a peering connection. So one side has to be the requester and the other side has to be the approver. So we'll make default VPC as the requester. Again, you have to select within your account, another account, this region, other region, and I'll select staging as the approver. So since I own both of them, I am the requester, I am the approver. So I'll just simply go ahead and accept it. So now I have connectivity across both these VPCs. So all what I'll need to do is create a route table, or let's modify one of the route tables that we already have. I'll add a route. So right now, this is under staging, so I'll have to pass on the address range for my default VPC. So this time I'll be more specific, and the target that I'll be selecting is peering connection. I'll be using this and save. So in the route table, if you find a more specific route, it would always take preference over the default route. So I'm being very specific that for this network, you have to go to this endpoint. So this endpoint is my peering endpoint. So if I save it, I've established the connectivity from my staging to default. So likewise, I'll have to do the same for the default VPC, wherein the target for default VPC that I'll choose is the network address range for this staging VPC. So once you have done that process on the default VPC as well, from connectivity perspective, you are good. So we have seen the process of initiating the request. One is the requester, one is the approver. Modify the route tails across both the VPCs. Make sure security groups allow the connections, and you are good. So I'd skipped ACLs and kept it for the last. So we have seen how security groups work. And until now, the security groups that we were creating, they were under the default VPC. So security groups are specific at the VPC level. So we've already seen multiple times the implementation of security groups. So we can only set up allow-only rules in security groups, and earlier we had said that they are stateful. At the networking layer, you can apply ACLs, which are access control lists. So these control the traffic at a subnetwork level. So why would you want the illegitimate traffic reaching at the compute layer and getting filtered at the security group level? So you may want to apply an additional layer of security in form of NACLs. By default, the ACL that is created allows all the traffic in this case. So this is the default NACL that it created, and it allows all the traffic both for inbound and outbound. So in case of NACLs, the moment it meets a match, it would be allow or deny. It would not execute the rest of the statements. So for example, so I'm able to connect to this instance. So what I'll do is that's simply because the default NACLs allow everything in the inbound. And the source that you see is, again, you don't know which source the user would try to connect to your application. So I can always do a edit. So NACLs, they operate in a sequential fashion. So if I set up a rule by the number 110, and let's say I specify a deny here. So in this case, rule number 100 says allow all the traffic. Rule number 110 says deny HTTP traffic. So rule 100 would be executed first, and the moment a match is met, it would not execute the rest of the rules that you have specified. So I'm still able to access the application. Whereas if I change the sequence number, let's say 90, now 90 would be executed first. So now I won't be able to access this. So NACLs, they are stateless, whereas security groups were stateful. Also, any changes that we do, they are applied on immediate basis, as we have seen. So you might get scenario-based questions where it would be referred that you're making changes to the security groups or NACLs. What is the overall impact that you would see? Likewise, you can set bound rules. And again, since they are stateless, you'll have to explicitly specify what traffic you want to allow. So in the case of security groups, we saw that if it has been permitted in inbound, so whatever the outbound rule says, it simply ignores it. Reverse traffic is allowed. Whereas in the case of NACLs, you'll have to explicitly specify. So NACLs, they are applied at subnetwork level. So if we see subnet associations, this NACL is associated with multiple subnets. So quick difference between NACLs and security groups: stateless, stateful. With NACLs, you set up allow and deny. Security groups allow only. And then with respect to subnet associations with NACLs, a subnet can be associated with one NACL, whereas an instance can be assigned up to 5 security groups, and each security group can have 50 rules. So 250 rules can be applied to computers. But more the number of rules you add, it's going to take time to process. And then NACLs are applied at the subnet level, whereas security groups at your compute layer, which are within a subnet. So that completes the session for the day. Have a great day ahead. Bye-bye.